Welcome students. Myself Ahirrao VA from Department of Instrumentation and Control Engineering. मराठा विद्याप्रसारक समाजास कर्मवीर ॲडव्होकेट बाबूराव गणपतराव ठाकरे कॉलेज ऑफ इंजिनिअरिंग नाशिक. Here the objective is to learn the soldering techniques. Outcome: students will be able to summarize the different soldering techniques. First of all, we will go for the meaning of soldering. Soldering is actually considered to be a brazing process but occurring at a lower temperature. We can define soldering as the joining of metals by a fusion of alloys which have relatively low melting points. For the soldering process, the few things are necessary. So first is the base metals which needs to be soldered. To carry out the soldering process, solder or solder metal is required. In addition to it, flux is required, and of course the heat is required. The solder or solder metal acts as wetting of the base metals forming the joint, then flowing between the surfaces, and it will act as a metallurgical bonding. Soldering techniques. The method of heat application to complete the soldering process depends upon the nature and type of joint, melting temperature of solder, which flux we are going to use. There are mainly two techniques to carry out the soldering process, and these are the iron soldering and mass soldering. First, we will go for iron soldering. As the name indicates, iron, so we have to use a solder iron to complete the soldering process. The different parts in case of soldering iron are insulated handle, metal shank which will contain the heater, and the bit, or also called as the tip. The figure will show you the different parts. The handle will facilitate the user to carefully hold the soldering iron and carry out the soldering process. It is the insulated one so that no any thermal hazard will take place to the user. Then a heater which will electrically heated, and that will provide the heat up to the melting point of the solder metal, and that heat will be carried up to the tip or bit of the iron. Depending upon the different points and metals to be soldered, the different solder metals used and the fluxes, the different wattages of soldering irons are available. The functions of the bit: first of all, to store the heat and convey that heat up to the work. Then it may require to store and deliver the molten solder and flux to work. And also, whenever we want to desolder, or to remove the surplus solder metal from joint, the bit will be useful. The figure shows some of the different bit shapes. Actually, the bits are iron cladded, chrome plated, and pre-tinned tips so that the user may select among the different available bits for the particular application. The second category is the mass soldering. As the name indicates, mass soldering, it means at a time many of the joints are getting soldered. Under the mass soldering, there are few types. Among them, the first is the deep soldering. So here there is the PCB on which certain components are mounted which needs to get soldered, and a solder bath is there which is electrically heated, and that consists of the molten solder. The PCB containing the components is held parallel to the surface of the molten solder. That PCB will be brought downwards till the bottom of the PCB will touch to the surface of the molten solder, and when you will lift the PCB after an optimum time, the soldering will take place. But in this method, which is known as the flat dip, the air may get intruded and the solder defects may occur. To avoid this one, the second method is there, which is called as the angled dip. The PCB is moved at certain inclination up to the molten solder, and that movement will be till the time the lower bottom part of the PCB will slightly touch to the molten solder's surface. Then it will be made parallel to the surface and the soldering process will take place. Again, while taking it out, it will get lifted by certain angle, and then the PCB will be moved away. In the angle dip, the excess molten solder will get automatically drained, and there is very less chance of air which is getting trapped between the PCB and the molten solder's surface. If we want to carry out continuously the soldering for certain PCBs, then the drag soldering is used. The PCBs are carried on a conveyor system. They will move onto the molten solder surface, and again, very similar to the angle dip, that PCB will be tilted as there is a tilting angle present for the conveyor, and then it will be taken out. The widely used third method, which is called as a wave soldering. Actually, when we have to manufacture and solder number of PCBs in short time, but if there is a continuous use of the soldering, then we will prefer the wave soldering method. There are few steps in the wave soldering method. First is the flux spraying. In case of iron soldering and deep soldering, the flux is separately applied. Normally, it will be the semi-solid flux, but in case of wave solder, there will be a liquid flux present, and the foaming will be resulted, and by foaming, the flux will get applied on the bottom side of the PCB. The next step will be preheating. In this phase, the temperature of the metals which are to be soldered as well as the flux, it will be brought up so that the flux will be active and it will be ready to cause the soldering process. Third step will be the wave soldering. The molten solder will be present, but by pumping, a wave will get generated, and when the PCB will pass over this wave, the soldering will take place. And the last step is the cooling step. Once the PCB will pass over the solder wave, the temperature will be very high, usually slightly greater than the melting temperature of the solder metal, and to prevent any of the component getting fall, we have to cool the PCB very quickly. The figure shows a typical wave soldering machine. Here the PCBs will be soldered one by one, but those are carried over the transportation system. The transportation system is nothing but a conveyor system which will be usually driven by the chain. The next step will be the flux coating system. So in a container, the liquid flux will be present, and the foaming bypassing the air will be resulted, and that will get applied at the bottom of the PCB over this area. Then next, the preheating zone will be there. When the PCB will pass over the preheating zone, the flux will be made active as well as the temperature of the metals to be soldered will be raised. The next system will be the welding system. Here there is a container or called as a solder bath, which will be electrically heated, and the temperature will be maintained slightly above the melting temperature of the solder metal. By pumping the solder metal through a narrow portion, the solder wave will be resulted, and as soon as the PCB will pass, the components will get soldered. And the last will be the cooling system. Usually with the help of few fans, the cooling will be provided at a faster rate so that whatever soldering that had taken place, it will be retained. Few types of waves which are getting resulted in the wave soldering process. The very first is the double crested. So from the center over this narrow region, the molten solder will be pumped, and it will come out of that zone from both the sides, and that's why the name is the double crested wave. The next is the flat topped. So the molten solder will come usually from only one side, and a wider surface area will be made available for comfortable soldering. The third one is the unidirectional one, which is almost similar to the flat top, but a narrower region will be available. When we are having the THT, means through hole technology, means components which when are getting mounted, that will get inserted into the PCB like the one shown here. So here first of all we have to complete the component mounting, then the flux will get applied from the bottom of the PCB, then that conveyor, as it is tilted at certain angle, the components which are mounted will pass over the wave of the solder metal, and then the soldering process will take place. But after each PCB passing over the wave, you need to carry out the visual check. Similarly, for SMD components, the wave soldering process is slightly different, as those are the surface mount devices. These are first attached to the PCB with the help of the adhesive. So first adhesive is applied, then the component is being placed. The adhesive will hold the component for short time. Then in the preheating zone, the adhesive will be cured so that for longer time it can hold the component at the right place. Then in a similar way to that of THT, the flux will get applied, but at this condition we have to invert the PCB because of the surface mount technology. Then that PCB will be passed over the wave of the solder. Once the components are getting soldered, then you have to carry out the visual check. Another method is also available, and that is the reflow soldering. Reflow soldering is very similar to the wave soldering process with few exceptions. The steps in the reflow soldering is: first the preheating, second thermal soak, third is reflow soldering, and fourth is the cooling one. If you will refer the figure, instead of the adhesive or glue applied to the component, a solder paste which will itself consist of the flux is applied to the pads where the components need to be soldered. Then there will be a visual check of the solder amount, because if that solder amount will be very less, improper soldering or less quality soldering will take place. Then there will be the mounting of the components. As it is a solder paste, it will try to hold the component at right place for short time. Then instead of the solder wave generated, as already the solder paste is being applied to the pads where the components need to be soldered, the heating will be applied. So when that PCB will pass through this heating zone, the reflow of the solder metal will take place because that heat will be sufficient to melt the solder paste, and that will cause the soldering process. After this one, you may check once again the soldering quality through visual check. References: first, Printed Circuit Board Design and Fabrication, Assembly and Testing, the book by R.S. Kanpur. Second book, Printed Circuit Boards by Boshat. And third, you may refer the PCB design tutorial at the website www.alternatezone.com.
Thank you.